Okay, good afternoon, everybody. We're so happy that you have joined us for Edible Ice Cream Aquifers today. My name is Ruth Kline-Robach, and I'm here with my coworkers Lois Wolfson and Laura Young, and we all work at Michigan State University, and all of us do water, fun water stuff. So we're so happy that you're here with us today. So we're going to start today by asking you all a question. We're trying to figure out who has joined us today. So we're going to put a poll question up. And if you will answer that question when you see it appear on the screen, we're just interested in who you are. So let us know if you are currently an elementary school student, a junior high student, senior high student, college student, a working adult, a retired adult. And if there are more than one of you at your screen, then you can fill out whatever fits. Okay, and I think we've all answered the question, and if Laura will share. So we have elementary and college. All right, cool. So we're gonna try to make our presentation today useful for all of you. So let's hop right into it. We are talking today about groundwater, but we can't really talk about groundwater unless we put it in the context of the whole water cycle. Sometimes we refer to this as the hydrologic cycle. So if you think about in your mind a satellite image of the Earth, and there's a whole lot of blue on it. 70 to 80% of the Earth's surface is covered with water. But all of that water just moves in a closed system. So it's in the atmosphere and it returns to the earth through precipitation by rainfall or snow. And then some of that water that lands on the surface runs off into our lakes and our rivers and our streams and our wetlands. Some of it is taken up by the trees and the vegetation and transpires back up into the atmosphere. But some of that water goes down into the ground, what we call infiltrates into the ground and becomes groundwater. And that's what we're talking about today. So I want to ask you all another question. Here's a second poll question. I want you to think about your drinking water. I have a glass of cold drinking water in front of me. Where do you think people in Michigan get their drinking water from? So the Great Lakes provide water for about half of Michigan's population, but where does everybody else get their drinking water from? Most everyone else, from groundwater, from rivers, from inland lakes, or from wetlands. What do y'all think? We'll give you time to answer. Looks like we're still waiting for maybe a couple people. Okay, why don't we share the results? And oh, you guys are smart. It's groundwater. Very good. So about a little less than half of the people in the state of Michigan use groundwater for their drinking water supplies. This map shows for people who are on public water systems where their drinking water is coming from. And all you need to pay attention to here is all of the red spots are people that are using surface water. So everybody along the coastal areas of Michigan is using Great Lakes water pretty much. And we have a few people, a few communities in the inland part of Michigan that use rivers and lakes for their drinking water. But really, most of us that live on the interior part of the state are using groundwater for our drinking water supplies. So what is groundwater? Because it's kind of hard to visualize and kind of hard to explain what we're talking about. But when we think about underneath our ground, underneath the surface, it is the point at which all of the pore spaces between the soil particles are filled with water. So it's kind of like a sponge, a full saturated sponge full of water. That's what groundwater is. So it's just different layers of sands and gravels and clay and rock that are filled with water. And different soil types have different rates that water will go through it. So a gravel or a really thick rock with lots of open spaces will allow water to travel faster through. And then something like a clay, water won't get through it very quickly. So groundwater moves at different rates through different soil types. So we're building aquifers today. And for those of you who aren't familiar with the term, aquifers are just different layers of sand and gravel and clay and rock that hold enough water for us to pump up and drink, to use for our drinking water. So we have lots of different aquifers in Michigan. I'm going to show you now what is called a groundwater flow model. And maybe some of you have seen this in a class that you have taken. What this is it's a kind of, some people say it looks kind of like an ant farm, but this is a model that shows what groundwater looks like. So it's beneath the surface. We have sands and gravels, and the gray color that you see there is clay. That's depicting clay. And we drill wells into the different soil types, and then we put a pump on, and then we pump that water out for our use. I'm going to show you now, I'm going to share a different screen, so it'll take me just a moment to pull it up. I'm going to show you a little video that shows how water is moving through the surface. So here's our groundwater model that I was talking about before. And we have different aquifers. So we have, this is an unconfined aquifer, everything in the red outline here. That's everything from the surface down to the first clay layer. And so water moves through, it comes into the system in an area of recharge when it rains or when it snows. What you're seeing here now is we've put some food coloring down into one of the wells. So we've got water coming in. Let's pretend it's raining. That's what we call recharge. And that food coloring you will see is moving the water through the pore spaces of the soil particles. This is how groundwater moves beneath the surface. Probably something that we haven't thought about before, because usually we don't really think about groundwater too much. So groundwater moves from higher elevations to lower elevations, just like surface water does, except it moves a lot slower. It's not like when you're standing on the edge of a river and you see the water whipping by really fast. Groundwater moves relatively slowly within the Earth's surface. But then what happens is it eventually discharges into the nearest surface water body, like a river. We sped up that video so that you could see it. Now here in the red outline is a confined aquifer. Let's put some green food coloring into this well, and the water will move again from higher elevations to lower elevations, and that clay layer is keeping the water from moving further up. And eventually we will see this green food coloring also going up into the stream, just like the red food coloring does. So groundwater and surface water are directly connected. Groundwater discharges, it goes up and puts water into our surface water systems. So it's all part of that big water cycle that we were talking about before. Okay, so I'm going to go back to my PowerPoint slide. Now we know what groundwater is and how it moves, and we're going to talk a little bit about what might pollute it. And I'm going to turn it over to Lois for that.
All right, hello everyone again. We have another poll question. This one is on what you just heard about groundwater contamination. So if your neighbor's well water is contaminated with some type of pollutant, it is almost certain that your well water will also be contaminated. Is that true or false? All right, let's go ahead and end the polling. And most people said true, but actually it's not really true. So let's go ahead and look at the next slide. So what we can see here are 3 different wells, and this red represents the pollutant, and it's called a plume. So the pollutant plume, and we can see that 2 of these wells are one's right in the plume or that pollutant, and one is just below it. But we can see this 3rd well, it's still the neighbor from these other 2, but yet its well is much deeper. And so their well water would not be polluted, at least from this particular pollutant, because there's some type of confining layer here that's preventing that pollutant from moving down to the depth of that particular well. All right, So now what we're going to do, what you've all been waiting for, is we're going to make our own edible aquifers. And I'm going to turn it over to Laura Young.
Good afternoon, everyone. Well, I'm really excited to help everyone here build our own edible ice cream aquifers. So before I start demonstrating how to put everything together, I just want to quickly go over all of the ingredients that you will need. And if you don't have them on hand right now, just jot some notes down and then you can follow up after the presentation today to build your very own edible ice cream aquifer. So the first thing you're going to need is a clear glass. So make sure you have that, and you're also going to need a straw. And the way that I'm going to quickly go through all the different layers and what they represent in terms of the aquifer, and then I'll help assemble our first edible aquifer. So at the bottom, we're going to have gummy bears, and those are representing that geologic material like gravel or sand that is holding in the groundwater. And we're going to add some soda pop on top of that, which is going to be our groundwater in our edible aquifer. And this is going to be a confined aquifer, like what Ruth was talking about, because on top of our gummy bears and our pop, we're going to add some ice cream. And that ice cream is going to act like a clay confining layer. And then on top of our ice cream, we're going to add some crumbled cookies, which is going to represent an unconfined aquifer. And then we're going to add some sprinkles, which is going to represent our top soil at the very top of the ground. And if you happen to not have crumbled cookies, you don't have gummy bears, don't worry about it. You could use chocolate chips or cereal or marshmallows. The main thing is that you have some ice cream, some kind of liquid, and then some different layers to help you distinguish. You could also use crushed ice as well. And one last thing that you're going to need is some colored juice, or you could use some food dye. And I will show you what we're going to do with that in a few minutes once we build our aquifer. So Ruth, how about you turn off the slides, and I'm going to start assembling our aquifer. So right here, I have some gummy bears, and I'm going to add them into my glass here. And now I'm going to kind of shake those around, and I'm going to get my pop, and I'm going to pour the pop just to the very top of my gummy bears. And again, we are building our confined aquifer right now. So I'm just adding just a little bit just to the very top of those gummy bears. So that's what it looks like right now. Now the fun part is I'm going to get some ice cream. So I have some vanilla ice cream, but you could use whatever you have on hand at home. I'm going to get a big scoop here and maybe add one more scoop because ice cream is delicious. And what's really important once you get your ice cream in is that you want to take a spoon, and just give me 1 second to put my scooper in there, and you want to pat down the ice cream. You really want to get a tight seal, and it looks like my ice cream kind of melted a little bit, so I'm actually going to add some more. Do this. You want to get a tight seal so that ice cream really does act like a confining layer. So I'm kind of pushing it around, trying to get it as tight as I can. And it's kind of maybe sat out just a little too long, but that's okay. We'll keep moving through this. So now on top of my ice cream, I'm going to add some Oreos. So I've got my Oreos here, and dump those in. And again, this is representing another aquifer, this time an unconfined aquifer. And then on the very top, I'm going to add in my sprinkles. So I'll pour those on top, and again, that's representing our soil. So right now, the aquifer is down here, a little tough to see because the ice cream kind of melted into part of it, but we do have this nice thick confining layer, that's our ice cream, and then we have our Oreos and our sprinkles. So now what I want to do is take my juice here that I have, which is going to represent some contamination. And we want to find out what happens to our confined aquifer down here at the bottom when we pour on some contamination at the top of our soil. Does it make its way down to our confined aquifer? And so what I'm seeing here is that all around, it's looking pretty good, but we're actually right here, we've got a little bit of a leak that's coming down through to the bottom of our confined aquifer right there. So kind of a slow leak in. And now what I want to do is take my straw, which is going to represent a well, and I'm going to drill a well all the way down into our confined aquifer. And I'm going to pump the well by drinking through the straw. And so let's see what happens to some of that contamination if it ends up getting into our confined aquifer here on the bottom. So I'm drinking some in, and actually you can see that it's starting to pull some of that contamination down into this confined aquifer here at the bottom. And we can also recharge our aquifer by adding some water, we'll call this rain, by taking our pop and adding some more at the top. Got some fizzies. And that is how you build your very own edible aquifer. So I think hopefully you all were able to follow along. And if you happen to have any pictures of your edible aquifers, feel free to post them on our social media channels, and I'll put those in the chat where you can tag us. And I think we have time for a few questions.
Laura, that looks delicious. Your
Yes,
aquifer looks very edible and yummy.
Very,
so
very
let's
tasty.
just, if you have questions, go ahead and put them into chat or into the Q&A. And I'll just say, just think as you go about your day and as you're talking to your friends and neighbors, things that might help protect our groundwater resources, being very careful not to dump anything on the ground or the soil, any kind of pollutants, making sure that you're recycling your oil, you're picking up your trash, being careful with fertilizers and pesticide use, anything that could potentially infiltrate or get down into the ground and become part of our groundwater, because each one of us has to play a role in protecting our drinking water supplies.
Well, we really, really hope that you enjoyed today's presentation and that you all get to make your own tasty edible aquifer at home.
Thanks
Thank
for
you,
joining us,
everyone.
everybody. Bye.